morning, guys. Welcome to another video clip. Today is a joint venture between Titan Marine and MrLopezClasses.com. Okay, today is a special day. We are going to talk about the integration in the typical boats, hybrid boats, solar boats, with the air conditioned units, AC units, and DC units. And today in this project, we are going to explain the procedure to integrate DC unit, self-contained 48 volts. This is nice. It's a great project. You can do exactly the same in an RV, in a motorhome. The procedure is the same. The process of integration is the same. But today we are going to focus the conversation in the ability, the capacity of those units. DC units in this particular case is a self-contained unit with a variable speed in the compressor. This is the most interesting part of the conversation. In the future, we are going to create other similar projects and similar videos with other products that Titan have in your office. For me, it's a pleasure to introduce to Hector Castañeda, my friend and sponsor in the majority of the electrical classes. I am training a lot of technicians for this company. And Francisco, thank you for coming.
Thank you, Mr. Lopez, for having us.
Thank you. For me, it's a pleasure. And we are going to start checking quickly the Victron system and how the DC unit is integrated in the system. Let me move the camera and I explain quickly the process. Okay, guys, here we have in this moment the shore power entering. The automatic transfer switch accepts the power from shore power. This is automatic transfer switch. If the generator starts, immediately the transfer switch passes to the position generator and start the generator. Okay, the power enter over there, and in the output, the power enter in the input of the inverter charger. This is the inverter charger. And in the output of the inverter charger, you feed the AC panel. In this moment, the AC panel is working. And the rest of the installation, you know that installation, the Servo GX, the display in this moment indicate that the grid provides 230 watts. The inverter is in absorption, is charging the battery bank, and we don't have AC loads in the AC panel. But we can start the AC panel. We can turn on the AC panel here, and we can turn the air condition, AC air condition 120 volts. And of course, immediately here change the consumption is 340 watts and the air condition is running. And this is the system. The system in this moment is in the mode charge. But we are going to concentrate, we are going to focus this conversation in the installation of the air condition, the DC air condition, not the AC. In this particular case, in this boat, in this prototype, we have the DC panel. The DC panel is 12 volts. This is why I installed, Francisco, the DC to DC converter to convert 48 volts into 12 for the DC panel. Because originally the boat was 12 volts. We are going to keep those parts, 12 volts. And the installation 48 volts, two batteries of 48 volts, 100 amps in parallel, negative with negative, positive with positive, and the fuse, the protection fuse. This is 48 volts, this is the shunt, and this is the gauge for that shunt. 48 volts, and we are going to provide here and here 48 volts for the AC unit. Okay, let's go to the AC unit. And this is the air condition unit, 48 volts, 48 volts entering here. The AC unit is running in this moment with this cooling tower. The cooling tower provide the water for the air conditioning unit. And what is the temperature actually?
The temperature right now is 63 Fahrenheit.
63 degrees Fahrenheit.
That's
okay.
Correct. Yep.
This is the output temperature. And the ambient temperature is 82, 83 right now?
Yeah, something like that.
Okay, perfect.
84.
All right, in this air conditioning unit, Francisco, can you explain how this unit works?
Okay, in this case, we're looking at a 48 volt system. This system works with a variable speed compressor and frequency drive. The unit is able to run essentially different speeds allowing the unit to be more efficient compared to an on and off system.
Why?
The benefits of having a variable speed is for the compressor to have a more linear consumption instead of those peaks that we get on and off every time the AC goes off and on. Every
That's
time,
interesting.
Correct. So every time we go on the on side, it creates a peak. This AC will work at maximum capacity equals to maximum consumption for an extended period of time until it reaches a set point. Once that set point is reached, the compressor will shut off and the cycle will repeat itself every time the temperature differential reaches 2 degrees.
Oh wow, but I have a question. The compressor by itself is AC.
The compressor itself is
Three-phase,
AC,
no?
Three-phase AC.
Okay.
Which allows to vary the frequency on the compressor, which in turn changes the RPM on the compressor motor.
With a frequency driver.
Exactly. All of these compressors are brushless systems, three-phase brushless motors.
Okay.
So it all adds to the end game, which is efficiency.
Okay. All right. And where is located the inverter here?
This will be our inverter, or as we call it, is a SSPM, which will convert the power from AC to DC back to AC, three-phase.
Yeah. Okay. Perfect. And this is the frequency driver also.
Yes, correct.
Okay. Great.
So the brains of the unit will command our frequency drive to give a specific speed to the compressor depending on the ambient temperature and the set point. So depending on which set point you have on your unit and the related ambient temperature, the brains will decide, okay, we have to work full load, and as we get closer to a set point, we're going to start decreasing the RPM, creating a more linear consumption line. And this would also keep the ambient temperature at a steady temperature versus having a decrease on the temperature on your ambient temperature inside your cabin, for example. And instead of the temperature going down, then having to rise up to 2 or 2 degrees for the compressor to start, the brain would essentially keep the speed on moderate the speed on the compressor to keep the temperature at a linear 70 degrees.
This is why in this moment the consumption in amps is 3.2 amps, 2.8, 2.7. It's nothing, no?
Correct, because in this moment we're working on the lower speed, so we're simulating now that the compressor has in fact reached or is very close to its set point and is working on its lower setting. And ideally throughout the night, the compressor will work in this mode, because now the thermal load is less because there's no sun outside. You already have a chief cooling the cabin by working the compressor at its maximum capacity, and right now we're working on the lower capacity, lower RPMs, lower power consumption, and no peaks.
In this particular case, we have a 2.7 amps of consumption, 2.7, 3.2, okay, 3 amps of consumption. This is great. You can run the air condition during the night with nothing, no? For 30 amps during the night.
Essentially, Mr. Lopez, yes. And this is what makes us proud to present this product in the shows and to educate the people on what it is that a variable speed can achieve.
The magic part of this equipment is the variable speed.
Correct.
Yeah,
correct. The magic of the system is being able to change that compressor speed and give us that efficiency.
That's great. That's wonderful. Excellent. And we are going to integrate in this prototype more equipment. What is your idea? What could be the next equipment? And water maker?
Yeah, our idea is to show people that want to be self-efficient, or the guys out there that want to be self-efficient, that there is products out there like the ones we handle with lower power consumption and same functionality as a traditional product.
Yeah, that's perfect. That's wonderful. Great. And when you install this type of equipment, you provide the entire solution. You install battery bank. You install the equipment completely.
For the most part, we take care of the AC side. We do have partners that do the electrical connection, and we're also able to do it.
Okay, where are you located?
We're located in Hollywood, near the airport.
The
Sterling
airport
exit.
in Florida.
Yes, sir.
You have excellent customer. I have a lot of friends that recommend your products in LMC Marine, in other marinas. I am too proud of work with you in this integration. Hector, thank you very much.
Thank you,
and Francisco, thank you. I appreciate your time, your generosity, because I know that it's time and it's money, because those equipment have a price, of course. Thank you, Francisco. Thank you very much.
No worries, Mr. Lopez. We're always here.
All right.